During 1950s, Herbert A. Simon and John Muth were jointly working on the solution to inventory management and production for a production firm, but with two opposing approaches. Simon used the doctrine of bounded rationality, which meant a person's limited ability in making appropriate decisions, whereas Muth propagated the idea of rational expectation. J. Muth's work lied between the relationship between expectations and reality. Expectations, as simply explained, is what people can estimate of a variable in its future based on some set of information available them about it. It then relies on the fact how accurate their expectations were, how they revised their expectations, and how very it adjusted with the actual value of the variable in future. For example, prices. If people base their information set on previous year's data in inflation and price movements, and if, say, prices have been growing steadily over the years, people thus make expectations about the prices in the future to also move in the same trend and hence rise steadily in the future. This very concept of basing the expectations on lagged information is the concept of adaptive expectations and is the sheer opposite of what rational expectation is. Another important example of formulation of expectation is found in well-known cobweb model, wherein the model describes the movement of the agriculture prices based on lagged prices in agriculture. Another example is the dynamic hyperinflation model, Kagan model 1956, in which velocity of money is inversely dependent on the expected inflation and expected inflation is a function of past inflations. His model has the property that an increase in the expected inflation will lead to the increase in the velocity of money, and when velocity rises, prices will rise. This rise in price, as expected inflation is a function of past inflation, the rise in prices will further increase expectations about the inflation in the future, and hence a vicious circle of expected inflation, velocity of money and prices has been explained in Kagan model. What is rational expectation? To simply explain rational expectation is to say, according to the doctrine of rational expectation, people, when making future estimated values of a variable, act rationally and do not tend to make systematic errors in predicting the future value of the variable with the given set of information. Progress in economics requires how expectation of a variable is formed. J. Muth suggested that economists are often interested in how expectations might change in certain circumstances, which means if an event occurs, what impact will it have on the expected value of the variable? To this, he said, economists should not be satisfied with the fixed expectation formulas that do not allow for change when the structure of the system changes. If underlying economic system changes, it will be wise to expect that there will be change in the way economic actors make their expectations. Hence, Muth suggested what rational should be done in a given economic system. Muth's insight was that it was possible to require economic agents to form expectations of economic variables by using the very model that actually determines these variables. The rational expectation hypothesis is the most popular approach to modeling expectations in the mainstream economics. The rational expectation hypothesis can be viewed as an attempt to provide neoclassical economics with a theory of expectations and beliefs formation that is a priori consistent with the optimization hypothesis. We owe its original formulation to Muth 1961, who suggests that expectations should be modeled in a way that allows them to change endogenously when the structure of the system changes. According to Muth, the rational expectation hypothesis implies that economic agents' subjective expectations are, on average, equals to the true value of the variables. In other words, it is only the average of economic agents' forecast that will be equals to the mathematical expectation of the variable. Thus, the forecast of a given individual may not coincide with the latter. A capsule characterization of rational expectation contains the following themes. First, in equilibrium, a steady state in dynamic terms, expectations are correct in the sense that individuals make no systematic forecast errors. Second, individuals use all available information as defined by the researcher in forming forecast. Third, expectations vary with the changes in government policies. And fourth, individuals know the model and thus can predict as well as economists manipulating the model. These are the tenets of the theory and are often espoused by its advocates.
After studying this module, you shall be able to know the concept of rational expectations, understand the implications of rational expectations, evaluate the shortcomings of the rational expectations, analyze random walk hypothesis. We start with studying the model of rational expectations, explaining the rational expectation hypothesis using an example. The market equations take the form Ct is equals to minus beta Pt. This is given as the demand equation. Pt is equals to gamma into Pt to the power e plus mu t. This is given as supply equation. And Pt is equals to Ct is the equation for market equilibrium, where Pt represents the number of units produced in a period lasting as long as the production lag. Ct is the amount consumed, Pt is the market price in the tth period, Pe is the market price expected to prevail during the tth period on the basis of information available through the t minus 1st period. Mu t is an error term representing, say, variations in yields due to weather. All the variables used are deviations from equilibrium values. The quantity variables may be eliminated from the equation to give the following. Pt is equals to minus gamma by beta into Pt to the power e minus 1 by beta into mu t. The error term is unknown at the time the production decisions are made, but it is known and relevant at the time the commodity is purchased in the market. The prediction of the model is found by replacing the error term by its expected value, conditional on past events. If the errors have no serial correlation and E mu t is equals to 0, we obtain the following. E pt is equals to minus gamma by beta into Pt to the power e. If the prediction of the theory were substantially better than the expectation of the firms, then there would be opportunities for the insider to profit from the knowledge by inventory speculation if possible, by operating a firm or by selling a price forecasting service to the firms. EPT is equals to PT to the power E. Referring to above equations, it can be observed that if gamma by beta is not equals to minus 1, the rationality assumption in above equation implies that Pt to the power e is equals to 0, or that the expected price equals the equilibrium price. As long as the disturbances occur only in the supply function, price and quantity movements from one period to the next would be entirely along the demand curve. By retracing our steps from the above equations, we see that the expected price would be Pt to the power e is equals to minus 1 by beta plus gamma into E mu t. If the shock is observable, then the conditional expected value or its regression estimate may be found directly. If the shock is not observable, it must be estimated from the past history of variables that can be measured. Now, we will discuss the implications of rational expectations. Muth framed his rational expectation hypothesis in terms of probability distributions, expectations of firms, or more generally the subjective probability distribution of outcomes, tend to be distributed for the same information set about the prediction of the theory or the objective probability distribution of outcomes. But Muth was also very open with the non-descriptive character of his concept. To Muth, Its main usefulness was its generality and ability to be applicable to all sorts of situations, irrespective of the concrete and contingent circumstances at hand. It is noteworthy that Lucas 1972 did not give any further justification for rational expectation hypothesis, but simply applied it to the macroeconomics. In the hands of Lucas and Sargent, it was used to argue that government could not really influence the behavior of economic agents in any systematic way. In the 1980s, it became a dominant model assumption in new classical macroeconomics and has continued to be a standard assumption made in many neoclassical macroeconomic models, most notably in the field of real business cycle and finance, being a cornerstone in the efficient market hypothesis. In rational expectation hypothesis models, new information is typically presented as something only reducing the variance of the parameter estimated. But if new information means truly new information, it actually could increase our uncertainty and variance. Information set AB is equals to ABC. Truly, new information gives birth to new probabilities, revised plans, and decisions, something the rational expectation hypothesis cannot account for with its finite sampling representation of incomplete information. Let us now study the shortcomings of rational expectation hypothesis. Models based on rational expectation hypothesis impute beliefs to the agents that are not based on any real informational considerations, but simply stipulated to make the models mathematically and statistically tractable. Of course, you can make assumptions based on tractability, but then you do also have to take into account the necessary trade-off in terms of the ability to make relevant and valid statements on the intended target system. Mathematical tractability cannot be the ultimate arbiter in science when it comes to modeling real-world target systems. Of course, one could perhaps accept the rational expectation hypothesis if it had produced lots of verified predictions and good explanations, but it has done nothing of the kind. Therefore, the burden of proof is on those who still want to use models built on ridiculously unreal assumptions, models devoid of obvious empirical interest. In reality, rational expectation hypothesis is a rather harmful modeling assumption since it contributes to perpetuating the ongoing transformation of economics into a kind of science fiction economics. If economics is to guide us, help us make forecasts, explain or better understand the real world phenomena, it is in fact next to worthless. Rational expectation hypothesis presupposes basically for reasons of consistency that agents have complete knowledge of all the relevant probability distribution functions. And when trying to incorporate learning in these models, to take the heat off some of the criticism launched against it up to date, it is always a very restricted kind of learning that is considered. A learning where truly unanticipated, surprising, new things never take place, but only a rather mechanical updating, increasing the precision of already existing information sets of existing probability functions. In rational expectations model, it is presumed a consistent behavior where expectations do not display any persistent errors. In the world of rational expectation hypothesis, we are always on average hitting the bull's eye. This model assumes that the expectations based on objective probabilities are the same as the subjective probabilities that agents themselves form on uncertain events. It treats risk and uncertainty as equivalent entities, but in the real world it is not possible to just assume that probability distributions are the right way to characterize, understand, or explain acts and decisions made under uncertainty. When we simply do not know, when we have not got a clue, when genuine uncertainty prevails, rational expectation hypothesis simply will not do. In those circumstances, it is not a useful assumption. The reason is that, under those circumstances, the future is not like the past, and henceforth we cannot use the same probability distribution, if it all exists, to describe both the past and future. We further study the random walk theory. The random walk hypothesis is due to Robert Hall 1978 and is based on Fisher's model and permanent income hypothesis, in which forward-looking consumers base consumption on expected future income. To this, Hall adds the assumption of rational expectations that people use all available information to forecast the future variables like income. In the permanent income hypothesis, as doctrined by Milton Friedman, and life cycle hypothesis, as doctrined by Modigliani, basically specified that households base their consumption on their permanent income and not on the transitory income. Thus, if PIH, that is permanent income hypothesis, is correct and consumers have rational expectations, then consumption should follow a random walk, that is, changes in consumption should be unpredictable. A change in income or wealth that was anticipated has already been factored into expected permanent income, so it will not change consumption. Only unanticipated changes in income or wealth that alter expected permanent income will change consumption. The independence of consumption changes from expected changes in income is known as the random walk hypothesis of consumption. Notice that the random walk hypothesis is not a separate theory but rather an implication of the neoclassical model. It was first explored in a seminal study by Robert Hall 1978. The discussion of random walk hypothesis would be like simple discrete time model with a zero rate of time preference and a zero interest rate. The zero interest rate implies that the consumer can trade current for future consumption at a 1-for-1 rate in the market. The zero rate of time preference assures that a consumer who is smoothing consumption is indifferent about making that trade. In the context of random walk hypothesis, Romer expresses the first order condition for utility maximization. The marginal utility of consumption in period 1 must equal the consumer's expectation of the marginal utility of consumption in each future period. Assuming rational expectations, we can associate the consumer's expectation with the mathematical expectation of the variable. Carrying the expectation operation through this, we can conclude that the expected value of consumption in all future years equals the level of consumption in period 1. As we know from our consumption analysis in the Ramsey growth model, utility maximizing consumers select a rising, flat, or falling time path of consumption depending on whether the interest rate is greater than, equals to, or less than the consumer's rate of time preference. Thus, the model is complicated even more when these assumptions are relaxed, but the main idea still holds, that is, changes in consumption from one period to the next do not depend on correctly anticipated changes in income. Romer explained what causes change in consumption from period 1 to period 2. The change in the household's expectation of its future income is based on information that becomes available in period 2. Thus, changes in expectations of income, even if they are changes that are expected to happen in future periods, will cause the household to revise its consumption path and make second period consumption differ from the first period consumption. Let us now discuss Hall's random walk hypothesis model. Hall's consumption pictures consumption as random walk trend. Take variable xt is set to random walk if value of x at time period t is its value at time period t minus 1 plus a random term which is uncorrelated with the past random terms. In equation, xt is equals to xt minus 1 plus epsilon t, where epsilon t is an id with mean 0. If E epsilon t is not equals to 0, then xt is to follow random walk with a drift. So, the actual model is Ct is equals to alpha plus beta into Ct minus 1 plus epsilon t, where alpha is close to 0 and beta is close to 1, and no variable besides last year's consumption will be useful in predicting the consumption in the current period to 0. In particular, this means that the residual epsilon t is uncorrelated with any variable whose value is known at t minus 1 or earlier. Y changes, consumption changes only insofar as the changes in income were anticipated. In a nutshell, Hall says it is exactly true if utility is quadratic and people have rational expectations and maximize their intertemporal utility function that a test for the RE or PIH comes from the regression. So, unexpected changes in the policy can change consumption up to the extent of its effect on the permanent income. Policies that have transitory on income have transitory effect on consumption.
Summary. Let us now summarize what we have learnt in this module. To simply explain rational expectation is to say, according to the doctrine of rational expectation, people, when making future estimated value of a variable, act rationally and do not tend to make systematic errors in predicting the future value of the variable with the given set of information. According to Moth, the rational expectation hypothesis implies that economic agents' subjective expectations are, on average, equal to the true values of the variable. In other words, rational expectation hypothesis is only an average of economic agents' forecast that will be equals to the mathematical expectation of the variable. Thus, the forecast of a given individual may not be same with the latter. Models based on rational expectation hypothesis impute beliefs to the agents that are not based on any real informational considerations but simply stipulated to craft the models mathematically and statistically tractable. The discussion of random walk hypothesis would be like simple discrete time model with a zero rate of time preference and a zero interest rate. The zero interest rate implies that the consumer can trade current for future consumption at a 1-to-1 rate in the market. The zero rate of time preferences assumes that a consumer who is smoothing consumption is indifferent about making that trade. So, unexpected changes in the policy can change the consumption up to the extent of its effect on the permanent income. Policies that have transitory on income have transitory effect on consumption. According to Friedman's permanent income hypothesis, consumption depends primarily on permanent income. At any point of time in their lifetime, consumption is chosen by consumers based on their current expectations about lifetime incomes. They would then change their consumption when they receive news that cause them to change their expectations about their lifetime income.